Welcome to Brain Vision.
In this question, there are three forces acting on the player: the weight force, the normal force exerted by the ground, and the frictional force exerted by the ground too. And in the first item, we have to calculate what is the magnitude of the frictional force. Note that the player is already moving, it is sliding on the ground. Therefore, we can calculate the frictional force using the following equation. The frictional force, in that case, where the player is already moving, is given by the kinetic frictional coefficient times the normal force. But in this situation, the normal force is exactly counterbalanced by the weight force. Therefore, what we have here is that the frictional force is equals to the kinetic frictional coefficient times the weight force. But the weight force is given by the mass of the player times the acceleration of gravity. Remember that the acceleration of gravity is approximately 9.8 meters per second squared near the surface of the Earth. Therefore, the frictional force is given by 0.49 times 81 times 9.8, which gives us a frictional force of approximately 390 newtons. So this is the answer for the first item. On the second item, we have the following. The player started to slide, and then after a time of 1.6 seconds, it comes to rest. So the final velocity is equals to 0. Then, what was his initial velocity? To answer that question, we can use the following equation. The velocity as a function of time is equals to the initial velocity plus the acceleration times that interval of time. Then the final velocity is equals to 0. So 0 is equals to the initial velocity plus the acceleration times 1.6, which is the time it took for the velocity to become 0. Then the initial velocity is equals to minus the acceleration times 1.6. Then how can we calculate the acceleration? We can use Newton's second law for that. Newton's second law tells us that the net force is equals to the mass times the acceleration. We will apply Newton's second law over the horizontal axis, which I will choose to be pointing to the right. Then, the net force on that axis is the frictional force, which is pointing to the left. So minus frictional force is equals to the mass of that player times its acceleration. Then, minus 390 is equals to 81 times the acceleration. Finally, minus 390 divided by 81 is the acceleration of that player. Then, the initial velocity is equals to 390 times 1.6 divided by 81. What happened to the minus sign? Well, there is a minus sign here and a minus sign here. So, minus sign times a minus sign is a plus sign. This is why the minus sign don't appear here. And then the initial velocity is approximately 7.7 meters per second. And this is the answer for the second item.